Welcome back, folks. In today's class, I'll be talking about the matrices. So I'll give you a brief introduction of the matrices, where it is used. It is used in a lot of engineering problems, especially one of the subjects if someone wants to study it in detail. It is used in the fluid mechanics. There is an equation called Navier-Stokes equation where we solve those kind of equations. Navier-Stokes equation, which has the 9 variable into it. We use matrices to solve that kind of a complex equation, because complex equations which has 9 variables into it is very hard to solve it by itself. So it's more of a mathematical tool which helps us to solve the complex equation in a little bit of an easier manner. So as I said, fluid mechanics is one of the examples. It can be used in the robotics also. Uh, and then the easiest example which you guys can correlate is it is used to solve the simple equation. So for example, if the equation is written as 2x plus 3y equal to 10, and here 5x minus 7y equal to 20. So something like this. If these are the two equations given to me, I wanted to find the solution of this equation. What we do is we use the elimination method. You might have learned it. So in the actually we learned the elimination method right in the beginning of the semester also. So how we can solve this equation, and then you get the x and y values, and you get an answer for that. So you can solve this whole thing by using the matrices also, which we're going to do it later on. So that was the bit of introduction about the matrices. Now we're gonna start with the basics. So matrix is represented in a big bracket form like this, and then there are elements into this one, which I'm representing them as a dot right now. And then another part of the matrix is called column. So this vertical dots, these dots, this they make a column. So this is one column, this is another column, and this one is the third column. So if I asked you to guess it, how many columns are in this matrix, there are 3 columns in this matrix. Is 3 columns. Now, then the second part of the matrix is the row. So this horizontal, these three will comprise of one row, and this is another row, and this is the third row. Now, if I wanted to write this matrix, this has three rows, and 3 columns, 3 columns. Now I can write this matrix as 3 by 3 matrix also. Now what is the meaning of 3 by 3 matrix? This first 3 will represent as the rows, and the second one will represent as the number of columns. So RC, this is the form in which it is represented. Now let's look into another example. If I put 2 dots here, and then actually I'm going to put 3 dots here. So this is one of the rows, and this is another row. So how many rows are there? There are 2 rows. And how many columns are there? 1, 2, 3. There are 3 columns. So this is a 2 by 3 matrix. Right, so hopefully you were able to understand the different terminologies which is used in the matrix formation. And this particular this dot is called element. So how many elements are in this matrix? 1, 2, 3, 4, 5, 6. 6 elements are present in this matrix. Now we're going to talk about the simple addition of the matrix. Adding of the matrices. So if there is a matrix, let's say this is 2 by 2 matrix, and then other matrix is also 2 by 2 matrix, I can add these two matrices. If the matrix, if the number of columns and the rows, if this is not same as the other matrix number of rows and columns, then I cannot add or subtract the two matrices. For example, here I wanted to add 4, 2, 3, 4, and 1, 2, 3, 4. These are the numbers given to me. If I wanted to add this matrix, yes, the number of rows is same as the number of rows of the other, and the number of column is also same as the number of column of the other matrix. So I can add them. So simply 4 plus 1, which is 5, 2 plus 2, which is 4, and 3 plus 3, which is 6, 4 plus 4, which is 8. So this will be your final answer. Now if I write a matrix as 1, 2, 3, 4, and add another matrix 1 and 2, because the number of rows are not the same, so this is number of rows is 2, Actually, the number of rows are same, number of columns are not same. So column is only one column in the second matrix. I cannot add them. I can't add this kind of matrices. So same goes with the subtraction also. So if I'm subtracting the two matrix, so for example, if I'm given the matrix 7 minus 9 minus 4 and 3, and I'm going to subtract another matrix from this one. Let me just quickly see whether it's recorded or not. Yes, it is. So minus 2, and this is 6 minus 8 5. I'm subtracting these two matrices. So 7 minus 2, that's well, this is minus and minus. So 7 minus and minus 2, 7 minus and minus 2, and then the second one will be equal to minus 4 minus 6, and the third one will be minus 9 minus and minus 8, and then the fourth one will be 3 and minus 5. So now 7 minus 2 is 9, minus 4 minus 6 is minus 10. This value will be uh, minus 9 plus 8. Minus 9 plus 8 will be minus 1, and down here it will be minus 2. So that will be your final matrix subtraction. Right, so hopefully you were able to understand how you add or subtract the two matrices. Now we're going to talk about the multiplication. So multiplication of two matrices. Alright, so when we talk about the multiplication of two matrices, we need to remember one of the formulas, that n times k, and if this is one matrix, if I'm multiplying it with k times m, then the final product will be equal to n times m. N times m. This will be final product of the matrix. So means that this is how the final matrix will look like: the n number of rows and m number of columns in that matrix. Whereas in the first matrix it was n number of rows and k number of columns, and here it had k number of rows and m number of columns. Now, if these two are not the same, you cannot multiply the matrices. If this has to be the k number of rows on the second one and k number of column on the first one. So if it is like 1 times 2, and I multiply it with let's say 3 times 2, let's say this way. So this, the number of columns on the first matrix, whatever we are using, first matrix, is not same as the number of rows of the second matrix. I cannot multiply these two matrices. So this matrix multiplication is not possible. And now if it is written like this, 1 times 2, and here multiply by 2 times 3. Now for this one, I will like you guys to pause the video and figure out what the final matrix will look like. Okay, so I hope you guessed it right. The final matrix will look like 1 times 3. So 1 times 3, because why we were able to multiply, because this 2 and 2 are same, so I can get the successful multiplication, and the final multiplication will give me this matrix, a matrix of 1 row and 2 columns. Alright, so based on this, we're gonna try and multiply two matrix. So let's say a matrix given to me is 2 minus 3 and 1. Here's 1, 1, 0 and 2. This is the a matrix given to me, and then another matrix b is given to me, which is equal to minus 1, 6, 5 minus 2, and this is 3, 0, 1 minus 4. These are the two matrices given to me. I wanted to multiply these two matrices. Okay, so let me see. This is a well, 3 rows, so 3 times 2, 3 rows, 2 columns, and this one has 2 rows, and 1, 2, 3, 4, 4 columns. Okay, so can I multiply these two? 3 times 2 and multiply by 2 times 4. Yes, I can multiply these two because 2 and 2 are same. So I can multiply these two matrices. If I reverse the order, if I write B matrix as the first one and the A as the second one, so it will become 4 times 2 multiply by 3 times multiply by, I'll represent with the dot, 3 times 2. Can I do this one? This is b times a. This was a times b. I I was able to do that because these two were same. But can I do this? These two same? I cannot multiply this. So I cannot say a times b is same as b times a. B times a. You know, we cannot. If I multiply b with a, uh, in this case it is not being multiplied. All right. Now the final matrix for the first one will come out to be 3 times 4. The three number of rows will be 3 and number of columns will be 4 in the first one. And the second, in this BA, we cannot multiply these two together. Now let's see the work of these two. So again, I'm going to write down the A matrix one more time, and I'll show you how we're going to multiply them also. This is 2, this is minus 3, and this is 1. This is 1 0 2, and then there is a B matrix which is equal to minus 1 6 5 minus 2, and the other matrix is 3 0 1 minus 4. These are the two matrices given to me, and I wanted to multiply these two matrices. So row of first one, so see this carefully, row of first one will multiply with the column of the second one. So I will write, and that's going to give me the first element, 2 times minus 1 and plus 1 times 1 times 3, 1 times 3. So this 2 goes with this one and 1 goes with this one, and that's going to give me the first element of the matrix. And then again I will use this one. Let me sharpen up the pencil. So this one multiply by this second one, so that's going to give me the second element. So that will be equal to 2 times 6, 2 times 6, and plus 1 times 0. That will be the second element of the first row. And then again first row multiply by the third one, so that's going to give me this one. So 2 times this will be 2 times 5, and then plus 1 times 1 times 1, 1 times 1. So this one with this one, okay, and this will be my third element of the first row. And the fourth one will be again 2 times minus 2, 2 times minus 2, and then 1 times minus 4, 1 times minus 4, plus 1 times minus 4. This will be the fourth element. So we got all the 4 elements of the first row. Same way we were gonna try and figure out the elements for the second row. So this will be minus 3 times this one. Again we'll go with this one, minus 3 times minus 1, and then plus 0 times 3, plus 0 times 3. This will be the first element of the second row. And the second element will be minus 3, see the pattern is being repeated now, minus 3 times 6, minus 3 times 6. This goes with this now, this one, minus 3 times 6 plus 0 times 0. Alright, then the third element will be minus 3 times 5 plus 0 times 1. And then same way fourth element will be minus 3 times minus 2 plus 0 times minus 4. Alright, and then you're gonna do for this one also. So this will be 1 times minus 1 plus 2 times 3. Okay, and then the second will be 1 times 6 plus 2 times 0. And then the third value will be 1 times 5, 1 times 5 plus 2 times 1. Alright, the fourth element will be 1 times minus 2, and then plus 2 times minus 4, 2 times minus 4. That's how you're gonna get it. And then we're gonna get the final answer from here. So 2 times minus 1 is minus 2 plus 3. Minus 2 plus 3 is going to give me 1, and this is going to give me second element will be 12 here, and this will be 11, and this will be minus 8, and then and then the next one will be equal to, oops, this one was 1 times, actually if this is 1 times minus 4, this is like this, 1 times minus 4, so that you're not confused. Then this will be 3 because this will be positive 3 and this will be 0, and then minus 18, minus 15, and this will be 6, and down here 5, 6, 7, and minus 10. So this will be final matrix, and this has how many rows? 3 rows. And how many columns? 1, 2, 3, 4 columns, 3 by 4. And did we say that it will be a final matrix will be 3 by 4? Yes, we said that it will be 3 by 4 when we multiply these two. All right, so hopefully you were able to understand how we gonna multiply the matrix or two different matrices. All right, then the next thing I'm going to talk about is the identity matrix. Identity matrix has only the diagonal elements, so this will be 1 1, this is 0 0. This is an identity matrix of 2 by 2 by 2, 2 by 2, because there are 2 rows and 2 columns. If I wanted to write an identity matrix of 3 by 3, so 1 1 1 0 0 0, only diagonal element is 1 and rest of the elements are 0. And if I wanted to write 4 by 4 identity matrix, so 1 1 1 1 0 0 0 0 0 0 0 0 0 0 0 0. So this is a 4 by 4 identity matrix. All right, so this was 4 by 4 identity matrix. And then one more thing I wanted to tell you is, if I multiply matrix, if you are given a matrix, that's a 2, 3, 4, 7. If you multiply it by identity matrix, you're gonna get the same matrix. Identity matrix in this case, because this is 2 by 2, I'll multiply it by 2 by 2 identity matrix. So the final answer will be 2, 4, 3, 7. That will be final answer. So A times I is equal to A matrix. That's what I wanted to tell you. If this is A matrix, this is I is identity matrix. That's gonna give you A matrix. Another thing I also wanted to tell you, the inverse. So if I multiply A with the inverse of this matrix, let's say this is 2 4 3 7, and if I try and find out the inverse, which we haven't learned, but I'll tell you later on, if I multiply these two, that's going to give me identity matrix. So I think that's enough for this video. I will see you guys with another video. In that one I will talk about taking the inverse of the matrix. So till then, goodbye.